This problem is to find continuity of piecewise functions at a point. Consider the function defined in two parts. If x is less than 0, then the function is given by x squared minus e to the x. If x is greater than or equal to 0, then the function is given by x minus 1. Determine whether this function is continuous at x equals 0. If it is not continuous, identify the type of discontinuity that occurs at that point. First step is to evaluate the left-hand limit as x approaches 0 from the left. Since we're approaching from values less than 0, we use the first part of the function x squared minus e to the x. As x approaches 0 from the left, x squared approaches 0, and e to the x approaches 1. So, the entire expression approaches 0 minus 1, which equals -1. Next step is to evaluate the right-hand limit as x approaches 0 from the right. Now, since we're approaching from values greater than 0, we use the second part of the function x minus 1. As x approaches 0 from the right, x minus 1 approaches -1. So the right-hand limit is also -1. Next step is to evaluate the function exactly at x equals 0. Since 0 is in the domain where x is greater than or equal to 0, we again use the second part x minus 1. Plugging in 0 gives 0 minus 1, which is again -1. Next step is to compare the two limits and the function value at x equals 0. The left-hand limit is -1. The right-hand limit is also -1. And the value of the function at 0 is -1. Since all three values are the same, we conclude that the function is continuous at x equals 0. The final answer is yes, the function is continuous at the point where x equals 0. To check if a function is continuous at a point, just make sure the left-hand limit, the right-hand limit, and the function's value at that point are all the same. That's it for this question. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel. If you're looking for tutoring on final exam level questions, check out my YouTube channel at MathTutor8285. You'll find helpful explanations and strategies to ace your exams.